Right, so by this stage you're going, oh, this is actually pud sticks, isn't it? No, okay, well, let me not be too facetious, but hopefully we're getting a sense, and I really want to keep instilling this, how linked all these concepts are. I mean, in each case, we end up kind of having this cast diagram for reference. This was basically just on the Cartesian plane, just in the first quadrant. Here we were, casting away, casting away, casting away. Okay, so let's cast away. It's not a move, anyhow. So determine the general solution. Okay, so now we're moving on to a general solution, but let's see if we can turn it into a cast type problem. In fact, I'm so confident that everything here is kind of casty that I'm just going to draw a cast diagram because I like them so much. So cast, C-A-S-T. Cos 2x minus 10 equals minus 3,42. Okay, 342. Oh, so minus 0, probably equal. Okay. Well, if that's that, then let's work out. Geez, I'm so just into solving it already. What's the first thing that we can work out? Now, I already want to jump to finding out what this angle is, because I want to get into that bracket. I want to find out what x is. General solution, I'm going to be doing a plus k times 360. We know that part because of the general solution, but I really want to get into this bracket to say, what's 2x minus 10? Well, we need to kind of do the opposite of cos. So let's see, what's the opposite of cos? We informally say it's shift cos. So let's find out what our reference angle is. So I'm going to write out the full word reference just to remind us that it's the reference angle, not the reflex angle. To say this is, well, the opposite was shift. Let me get that right. Let's see who's watching the video and who isn't. Shift, ask amongst yourselves and you'll see what I mean. Shift cos of 0,342. Okay, 70, and that's convenient that we're going to round this off to 70 degrees. I can't remember what it said at the front of the test paper. I guess we should check. Answers should be to 1 decimal place. Okay, so 1 decimal place means that we should, strictly speaking, say 70, 0. But I'm just going to say 70. So we've got here, and we're going, well, our reference angle is 70 degrees. And we just punch this in without that minus, and then start going, now which quadrants, so that's our reference angle. That was easy, shift cos. Now our reference angle is 2x minus 10. But not quite 2x minus 10 equals 70 just yet. Let's just see which quadrants we're working in. Okay, cos of something is negative, so it must be, no, all things are positive. They're all trig ratios in these two quadrants. So in other words, we must be there. So that's 70. I could have drawn that a much better. That would be 70. So in other words, our first solution, you with me, that the idea of going which quadrants, so you know how to do it. That's the one. And the second solution would be which quadrant? This quadrant, I think we said right. So if that's 70, then our second angle is going round to that line. Okay, so you've got your two angles. Let's see if I can rather turn this not into the memo, but just say that theta, but wait, theta's 2x minus 10. Remember in the Edpuzzle I said, no, I shouldn't have said theta, it should have been 2 theta or something like that, or theta plus 90. Good idea reducing that, by the way. Equals whatever this angle is. Let's write this so that I'm not answering the whole question and saying 2x minus 10 equals the pink angle plus k360. And the other option, I'm just going to write or down here so that we can solve our equation in that space. And the other one was in red, or 2x minus 10 equals whatever that angle is, plus k360, and in each of these cases, k is integer, and yeah, remember we want to find what x is, so just do some steps so that you have x equals whatever it equals, and in this case x equals whatever it equals.